This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're going to continue with graphing sine and cosine. In these examples, we're going to look at graphs that have a phase shift. We've looked at this a little bit before, but we're going to look at it in more depth in this video. So the main strategy that you want to use when you're graphing sine or cosine is to pay particular attention to the phase shift, because when we're graphing this, we want to graph usually two complete periods. And if we start our chart here at 0, we're going to be starting it somewhere in the middle of a period. And we want this first point to be the beginning of a period. So if we use our phase shift value, if we figure out how much we've been shifted to the left or the right, and we use that as our first x value, then that's going to make sure that when we graph our 5 key points, we're going to get one complete period, and then we can just repeat that to get a second period. So let's go ahead and get started with this one. We've got a as 2, we've got b as 1. Remember, this is bx minus c, so c is actually going to be positive pi over 2. If it was positive here, if it was x plus pi over 2, that would be x minus negative pi over 2, which would make c negative. So it's kind of like the opposite. There's no d, so there's no vertical shift. Our domain, as always, is all real numbers. We can see that my amplitude is going to be 2, so this is going to go from negative 2 to positive 2. Amplitude is the absolute value of a, which is 2. Period is 2 pi over b, which is 2 pi over 1, so that's 2 pi. My phase shift is going to be c over b, so c is pi over 2, and b is 1, so that's just pi over 2. So the whole graph has been shifted pi over 2 to the right because my phase shift is positive. Vertical shift is d, so that's 0. And my distance between key points is period divided by 4. So that's 2 pi divided by 4, which is pi over 2. Okay, so as I was mentioning, we want to start our chart at the phase shift value. So normally this first point would be 0, but now it's shifted over pi over 2. So we want to start at pi over 2. And then same as always, we're going to add the distance between key points, which is pi over 2 also. So 1 pi over 2 plus another pi over 2 is 2 pi over 2. I'll go back and reduce that later. Again, add the distance between key points, 3 pi over 2, 4 pi over 2, and 5 pi over 2. So this is going to be pi, and this is going to be 2 pi. And if you notice, we ended at 5 pi over 2, and we started at pi over 2. The distance between those, 5 pi over 2 minus 1 pi over 2, is 4 pi over 2, which is 2 pi. Notice this matches with our period over here. And that's really how it should be. These 5 key points should give us one period. All right, so let's go ahead and calculate our y values for these. So we've got f of pi over 2, so that's 2 sine pi over 2 minus pi over 2, so that's 0. So 2 times the sine of 0 is 2 times 0, which is 0. Remember, we're just using the unit circle. And I've got 0, pi over 2, pi, 3 pi over 2. And since we're looking at the sine, we're looking at the y-coordinate at each of these spots. So sine of 0, we're over here. The y-coordinate here, 1 comma 0, is 0. All right, moving on to the next one. So that's 0. F of pi, so that's going to be 2 sine pi minus pi over 2. So that's 2 pi over 2 minus 1 pi over 2. So that's pi over 2. So that's 2 times sine of pi over 2. We're up at the top. So that's 0, 1. The y-coordinate is 1. So 2 times 1, which is 2. And f of 3 pi over 2. That's going to be 2 sine 3 pi over 2 minus 1 pi over 2. So that's 2 pi over 2. Well, this is going to be pi. So 2 times the sine of pi, we're over here. That's negative 1, 0. We want the y-coordinate because it's sine, so that's 0. And, well, that should be 2. And that's 0. Okay. Then we've got f of 2 pi. So that's going to be 2 sine 2 pi is 4 pi over 2 minus 1 pi over 2. So that's 3 pi over 2. So the sine at 3 pi over 2, that's 0, negative 1. Again, we want the y-coordinate because it's sine. That's going to be negative 2. And if you want to go ahead and do the last value, go ahead. Otherwise, I can see the pattern here. We're going 0, 2, 0, negative 2. This one's got to be 0 one more time. All right, so we'll go ahead and mark our graph, our axes, and graph these points and then graph another period. So our distance between key points is pi over 2. So let's go every other to spread it out a little. So that's 1 pi over 2. That's going to be 2 pi over 2, which is pi. 3 pi over 2. 4 pi over 2, which is 2 pi. 5 pi over 2. 6 pi over 2, which is going to be 3 pi. 7 pi over 2, 8 pi over 2, which is 4 pi. Let's go one more time, 9 pi over 2. All right, so we have pi over 2, 0, pi over 2, 0, and then pi was 2, and then 3 pi over 2 was 0, 2 pi was negative 2, and 5 pi over 2 was 0. So I can draw in one period here, and then we'll continue and draw one more. We're 2, 0, negative 2, 0. Sketching my curve. Make sure that you have a nice smooth curve here and you're not drawing segments in between the points. All right, so that's one example of a phase shift. So you can kind of see that this has been shifted over pi over 2, because normally this would have looked something like this. You don't need to draw this in, but this is what it would have looked like. So you could see it's been shifted over. Every point's been shifted over to the right, pi over 2. So if you have any questions, make sure you ask. Let's move on to the next video, or the next example. Here's a cosine problem. So we'll do one cosine problem, and then we'll let you try the last one on your own. Again, if anything goes too fast, feel free to pause and rewind. Ask me questions when you see me. So I've got negative 4. B is pi. C, now it's going to be negative pi because it's pi x minus negative pi. That's how we get that plus. Again, D is 0. Our domain is going to be all real numbers. We know my amplitude is going to be 4, so we're going to be going between negative 4 and 4. Our amplitude is absolute value of A, so that's 4. My period is 2 pi over B, so that's 2 pi over pi. So those pi's cancel out, and we're left with 2. Phase shift is C over B, so that's negative pi over pi, which is negative 1. Vertical shift is D, which is 0. Distance between key points is period divided by 4. So that's 2 over 4, which is 1/2. Okay, so again, we're going to take this value, and that's where we want to start, because my whole graph is going to be shifted 1 unit over to the left. So we're going to have negative 1, and then we're going to add my distance between key points, which is 1/2. So if I'm at negative 1 and I add 1/2, I'll be at negative 1/2. Add 1/2 again, I'm at 0. Add 1/2 again, I'm at 1/2. Add 1/2 again, I'm at 1. Then let's go ahead and figure out these values. I have f of negative 1 is equal to negative 4 cosine. So it's going to be negative 1 times pi. So that's negative pi plus pi. So that's going to be 0. So I have negative 4 times cosine at 0, that's the x coordinate at 0. Remember, draw your unit circle on the side if you need to. That's going to be 1, so that's negative 4 times 1, which is negative 4. And let's move on to the next one. So I have f of negative 1/2, so that's negative 4, cosine, so negative 1/2 times pi up here is going to be negative pi over 2, negative pi over 2 plus pi. So if I add those, I get pi over 2. Again, if you're not sure about the fractions here, make sure you ask me. So I have negative 4 times the cosine at pi over 2. That's at the top of the unit circle. The x-coordinate is 0, so that's 0. Then I have f of 0, so that's negative 4 cosine. So I have pi times 0, which is 0 plus pi. So it's going to be cosine of pi. So that's negative 4 cosine at pi is negative 1. That's on the left side of the unit circle, so that's 4. F of 1/2, that's going to be negative 4 cosine pi over 2, because that's pi times 1/2, plus pi. That's really 2 pi over 2 plus 1 pi over 2, so that's 3 pi over 2. So that's negative 4 times, we're at the bottom of the circle, the x-coordinate is 0. And let's do the last one. F of 1, so that's negative 4 times the cosine, so that's going to be pi plus pi, or 2 pi. So again, we're on the right of the unit circle, so that's negative 4 times 1, which is negative 4. So I know a lot of you have noticed this already, but if you notice the pattern after we simplify the stuff in parentheses after our trig function, we're always getting these same values. So if you did it right, you know once you simplify inside these parentheses, you should always get 0, pi over 2 pi, 3 pi over 2, and 2 pi. If you didn't get those values, you should go back and check your values up here. Check your period is right. Make sure your phase shift is right. Make sure your distance between key points is right. Make sure you've labeled all of your x coordinates that you want to plug in correctly. You know, because every time when you're graphing sine or cosine, you should get 0, pi over 2 pi, 3 pi over 2, and 2 pi in the parentheses after the trig function, after the sine or the cosine. All right, so let's see, I had negative 4, 0, 4, 0, negative 4. And my distance between key points is 1/2, so I'm going to make all of my marks here 1/2. So I've got 1/2, 1, 3/2, 2, that was 4/2, 5/2, 6/2, 7/2, 8/2 is 4. Let's go one more, 9/2. So my first point is, I need to go to negative 1. So negative 1/2, negative 1. So I have negative 1, negative 4. So that's going to be here. Negative 1/2, 0. And then I had 0, 4, 1/2, 0, and 1, negative 4. So these were my 5 key points. I'm going to draw a nice smooth curve in there. And I'll repeat the pattern. So 0, 4, 0, negative 4, draw in one more period. Okay, and there we have 2 periods. Again, if you have any questions, make sure that you're writing those down and asking me. Go ahead and try the next example. That's going to have a phase shift. It's also going to have a vertical shift, so be careful with that. And you can check your answer with me in class. I'll have that solution for you. So we'll see you next time.